It's important to remember that the outcome is not the goal. It's how much you expand in the process is the goal.
Oh, whoa. Whoa. Oh my god. Oh my god. It floats. Wow.
You reach the top. Oh my god. Oh, it's still going up.
But I don't know how the water rises.
It's because.
Hey everyone, my name is Shane Watson, and I wanted to provide, maybe we can call this the director's cut of the session that we had earlier today. And I want to do that in the sense that without the context, I don't think that the full value of the final stage, that little assessment, can be fully appreciated. Because so much of this assessment really is on the process that the students go through from seeing the initial stimulus all the way to developing that model. And as we said earlier in a quote, the outcome isn't the goal. It's how much we expand in the process. So the model at the end isn't necessarily the goal. It's all the skills and the understandings that the students develop between the stimulus and when they're doing that final model, right? The co-constructing understanding, the communication, the observations, the mini investigations and whatnot. So I wanted to share a little bit of that process with you in this video. One of the goals, or one of the reasons why I start using models is we want to give the students in the class the opportunity to function like a professional group of scientists, like a community of scientists, right? So if you're at the frontier of science, you don't know what's happening or you can't explain it anyway. You see things and you're not sure how they fit into the bigger picture. And one of the reasons why I start using with models is because they start off with something that makes them go, that's kind of funny, or how does that work, or something along those lines. And what I find is that this type of structure or investigation leads to them wanting to learn more. I think that's called productive learning, right? So productive learning is the more they learn, it's like a positive feedback loop, right? So they learn a little bit and then they want to learn more, and then they want to learn more. And I think that's an important part of the scientific endeavor. And that motivation just to know more will trump them getting a grade. Like the idea is for them to forget that they're in the middle of a lesson, and then they just end up focusing on trying to be able to explain why something's happening or how it's happening the way it is. So quite often when I'm introducing models, I'll have these up and around the room. On the right hand side, you see ABCD, accurate, big, colorful, detailed. And these are kind of a rule of thumb of what your models should look like, right? So they should be big, they should be colorful, and they should have the right amount of detail. The accuracy is what we're working towards as a community of scientists, right? We're co-constructing that understanding, right? The left-hand side, the visible and invisible. Quite often students will just include what they see, and they do not represent the invisible. So a large focus is on getting the students to represent the invisible, because that's usually what's making the cool things happen. So this is something I used maybe 2-3 years ago, and it was the first time I was assessing models with students. We spent about a month just working on models and using different stimuli to try to explain. And the rubric on the bottom right-hand corner is a student-generated rubric. I thought that it would be there would be some value for the students to take a look at all the models that we did in the first month and begin to pull out some of the things that they thought made the model really effective. So this rubric is far from perfect, and I just felt that there was a lot of value in having them develop their own rubric, and then they would have this page when they were doing their assessment. And so on the day of the summative, they come in and we're in the lab, and they have access to the original phenomena. So, for example, the candle water flask, they have access to the candle, there's water there, and there's a flask. They get to redo the investigation. If we're doing the balloons with the hot hair dryer, they have access to that as well. And the idea is that they can recreate the experience, right? So they're not trying to go from memory. They might make some more connections that they didn't originally. And then there's going to be 2 that they haven't seen. So there's going to be 2 or 3 that they have, and then there's going to be 2 that they have not. The next video that you're going to be seeing is a modeling assessment I did with my previous school. The students are going to be seeing 3 models that they've worked with before and 2 that they have not. This is an example of student work from somebody in grade 2. And if you were just to use the things on the right, accurate, big, colorful, and detailed, visible and invisible, which one of those do you think he achieved? You know, certainly big. It's colorful. There's enough detail to describe what he saw. The description is pretty accurate. However, he's missing the invisible, right? He didn't include what was happening with the air molecules. He didn't include the consumption of oxygen and the production of carbon dioxide, which would explain why the candle went out, okay? He didn't include the change in air pressure due to the heat from the candle, right? And then when the candle goes out, the air pressure changes. So he didn't include any of that. But for somebody in grade 2 who spent half an hour, I was really happy with what he did. Here's an example of somebody in grade 4 learning how to represent the invisible. Again, holding on to the ABCD. One of the other things that I like about using the models is if we were to take a look at the book written by Tanya Latanzio called Taking the Complexity Out of Concepts. If you look at the levels of understanding, 1, 2, 3, 4, 4 is analyzing and applying. Most of your time spent developing models, working with the phenomena, is all those things you see in the level 4 verbs. One of the things I try to bring to the class is an attempt at authentic discovery. It may not be the first time that somebody's discovered something, but if it's the first time for the student, the sense of accomplishment, the experience is the same. And in my mind, there's no reason why students should have to wait until they're in university getting their doctorate before they're on the frontier of science. They can be on the frontier of science, of their science, every day. Thank you so much for listening.